In lesson 1.5, we're going to talk about triangles and some special quadrilaterals. So in order to know something is true in this section, you can't assume it. There are certain things that you can assume, however. For example, you can assume that all lines are straight. You can assume that all points on a line are collinear, and that two lines intersect at a point, and that all points are coplanar unless shown otherwise. Some things that you cannot assume are parallel lines, perpendicular lines, congruent angles, and segments or polygons being congruent. You have to see markings. So notice down below here, there are some things that you have to see in order to know certain things to be true. For example, down below we talk about these parallel lines. Without these markings on the lines, I would not know that. I have to show that they're parallel by marking them and indicating that they are indeed parallel. The same is true for the perpendicular lines. Notice that if I want to talk about perpendicular lines, I need to see that little box that talks about perpendicularity because it shows a right angle. So it's very important to see these things. You cannot assume that. Down below in the two figures, the reason that I know that these two triangles are congruent is because I see that they have, and we'll learn later, three sides matching up. It's called the side-side-side postulate, which we'll get into later. But I know that this is true because when I see that one side from one triangle matches with another, and that a second side is matching up with another, and then finally a third side matches up, I know that these two triangles indeed are going to be congruent. So these two triangles down below I can say are congruent because the markings indicate that. And in a triangle, if you have three sides matching up, that would be okay. Special kind of postulate for triangles. Some special triangles classified by their angles. So every single thing that you see here on this page when we're talking about triangles are classifications, and all these classifications are by the angles of a triangle. So there are three of those. So when we look at the angles, one classification is that something might be a right triangle. That's if you have a right angle. It could also be an acute triangle. That's if all three angles are less than 90 degrees. And it also could be called an obtuse triangle if one angle is more than 90 degrees but less than 180 degrees. So there are three angular classifications of triangles: right, acute, and obtuse. The right has a right angle in it, so you can see the box, or 90 degrees. An acute triangle has three angles that are less than 90 degrees. Usually they'll put the numbers in there. And an obtuse triangle has exactly one obtuse angle in it, and so that has to be an angle that's more than 90 but less than 180. Funny enough, there are also three side classifications of triangles. So when you're talking about triangles, you can also classify by the sides. On the previous slide, we talked about classifying by angles. Now when we classify by sides, one way to classify it is something that's a scalene triangle. That's when none of the sides are the same. So if none of the sides are the same, and you want to talk about how to talk about this triangle in particular with its sides, you'd say it's scalene because none of the sides are the same. If you're talking about something called an isosceles triangle, which is referring to the sides again, it means that it has exactly two congruent sides. And if you talk about something that is an equilateral triangle, that means it has exactly three equal sides. So the three classifications of triangles by their sides are scalene, isosceles, and equilateral, and they mean in order that there are no sides equal, two sides equal, and three sides equal. Now we get into the polygons that are not triangles. And so there are a few special kinds of those. One kind is something called a trapezoid. Trapezoids are defined by a quadrilateral, which means four sides, that have exactly one set of parallel sides. So notice that these markings on the four-sided figure are indicating that they're parallel, and we have something called a trapezoid because of that. If, in addition to the parallel sides that we saw earlier, which indicates that it's a trapezoid, we also see other markings which indicate the non-parallel sides are congruent, then they call that an isosceles trapezoid because two sides are equal and the other two are parallel. So an isosceles trapezoid is a special kind of trapezoid. Two parallel sides and then two congruent sides, and the congruent sides are the ones that are not parallel. The third type of figure that we're going to talk about is something called a kite. Now a kite is an actual definition in geometry. It has two sets of disjoint sides being congruent. That means they're on non-connected or not together, the two sets that is. So I'll notice that number one, I have a set of congruent sides on the top, and then second, I have a set of congruent sides on the bottom. I could have also drawn this figure sideways and then be right and left as an example. So kite, well, you'll see exactly what you see up on the board, two together and then two together. And they're different sizes. So maybe, just as an example, I might tell you that these sides are 3 and that these sides are 7, kind of thing. And then this last group has a lot of things going on, and they kind of build on each other, so you kind of have to pay close attention to this. So in a parallelogram, one of the things that you need to know in a parallelogram, first of all, is that the most important thing about a parallelogram is it has two sets of opposite sides being parallel. So here's one set in the green, and then here's another set in the blue. That's the definition of what a parallelogram is. Now, kind of the cool thing is also on that figure with the blue and green arrows that you see there, you'll also notice that the dots are there marking opposite sides are congruent. That is another thing that is also true about parallelograms. So in addition to the opposite sides being parallel, which is the definition of a parallelogram, you will also see that it has two sets of opposite sides congruent. Now that's not the definition of the parallelogram, but it's also characteristic of the parallelogram. The second item that we're going to talk about is a rhombus. Now a rhombus is the same thing as a parallelogram, but it has one distinguishing feature extra. It's equilateral, as you can see here underlined in pink. That means if I look at that, when I say equilateral, that means all four sides are the same size. So you see these dots here? Those dots in pink are representing that all four of the sides are congruent. So a rhombus is a special parallelogram, which is a special quadrilateral. So it's a more specific definition of something. So in a rhombus, there are four equal sides with opposite sides being parallel. A rectangle, on the other hand, is a parallelogram that has four right angles. So notice it doesn't have the four equal sides, but there are four right angles. So a rectangle is a parallelogram. In other words, it has all of the characteristics that a parallelogram has. Opposite sides are parallel, opposite sides are congruent, but it also has four right angles. So that's really important. And then last but not least is a square is a rhombus and a rectangle. So if you look at defining a square, it has every characteristic that a rhombus has and every characteristic that a rectangle has, which means a square has opposite sides parallel, It has opposite sides congruent, and also all four of them are congruent. And it also has 4 right angles. So it is the most specific and special of all the quadrilaterals.